Hi everyone, welcome to Alice and Bob. Today we are going to talk about a new blog post from Robert Habermeier, the co-founder of Polkadot. And the blog post is called Hybrid Chains. Every chain should have smart contracts. And in this article, Robert Habermeier is making the case for why app-specific chains should always have some smart contract functionality. And this makes sense in the context of where he is active, and that is Polkadot and the Polkadot ecosystem, in which you have a lot of app chains. Chains with app-specific use cases that are very specialized. And yeah, I'm not going to take too much away from his argument because he is actually opening with this. So we're going to read into this and I'm going to comment from time to time. And what we're going to see is that he is arguing for a system where app-specific chains offer smart contract functionality to combine the advantages of generalization and specialization and generalization into hybrid chains. Chains which offer the best of both worlds. So, application-specific block. Okay, now let's start with the title. Hybrid chains. Every chain should have smart contracts. Application-specific blockchains or app chains are highly uncontroversial today. The multi-chain ecosystem will evolve such that each chain specializes in one or two specific tasks, which are either user-facing or intermediate products. And applications will be composed of interactions between these chains. It's the natural conclusion of the multi-chain vision, right? So what he's saying here is that the multi-chain vision basically states that you have highly specialized chains, similar to how you have highly specialized components in a computer. You have a CPU, you have a graphics processing unit, you have memory in modern computers. You will also have AI-specific processors. And so these are specialized components and they are talking with each other. And the multi-chain vision is very similar in this regard in that you have specialized components that talk to each other and the applications will emerge between or above all of those features, using each of those features as they see fit. And this is the multi-chain vision, right? To answer this question, we have to dive into the differences between synchronous and asynchronous composability. I define composability here as the ability for two or more programs executed in one or more consensus environments to interface and interact with each other. By programs, I mean things like smart contracts or substrate palettes or specialized logic. Those programs are synchronously composed when the results of their interaction can be computed on a single computer without waiting on others. Programs are asynchronously composed when the results of their interaction require input from other computers. So he's comparing computers with the logic that you can see in a blockchain, which makes a lot of sense since a blockchain is very similar to computer in that it works from moment to moment to moment, block to block to block, and is performing executions moment to moment to moment. And this notion even goes as far as in saying that Polkadot has a number of execution cores, and a parachain or a parathread gets allocated one of these execution cores. So whenever a parachain is producing block by block by block, this is matched with an execution core. And in the future, there might even be a less strict combination where a chain could maybe rent multiple execution cores to process blocks. So here's a rule of thumb for making this a bit more concrete. Operations executed within an atomic transaction in a single block are synchronously composed, even if the transaction touches many different components or smart contracts. So if you have a single block, everything that gets executed in the block is synchronously composed because it can all be computed as a single unit. Operations which touch many blockchains or state machines, even if those chains are under the same shared security umbrella, are asynchronous. These operations require logic to be triggered on other chains before the end result can be seen, and so require waiting on machines which relay and process messages on remote chains. So you have one parachain and it is producing block by block by block, but if it relies on another chain, the block cannot wait on whatever is happening on another chain before it concludes. So there is a block, and then there is maybe a message generated for another chain, or the task generated for another chain to execute, and then it is sent over. But in the meantime, the parachain keeps on producing blocks. And in parallel, the other parachain can process the message that it received. So this is why they are asynchronous. The parachains keep on producing blocks even though they are communicating. The properties of synchronous and asynchronous composability are what led us to the app chain thesis to begin with. The benefit of synchronous composability is tight and fast integration, while the drawback is the scalability limits of a single blockchain. So this is, for example, what you see in Ethereum right now. Ethereum is a general purpose virtual machine, a computer, but it is limited in scalability to, and you have a lot of tight integration. You have a lot of apps, decentralized apps running on Ethereum at the same time, and they can call each other. So you have a very tight and fast integration. But the scalability is limited because Ethereum cannot specialize. It can only ever offer the EVM, and you build everything on top of the EVM. And if you want to get better performance for something, it cannot be done on Ethereum. So this is where you go into a multi-chain world. The asynchronous approach lets us split work across many chains and scale further, but introduces expensive round trips and message passing as a result. We realized we were going to need many chains, whether they were sidechains, parachains, or zones, and what we could further optimize each chain for specialized use, and that we could further optimize each chain for specialized use cases. And we could then combine these chains to achieve a more efficient ecosystem. So you can have a more efficient ecosystem if you have more specialized components, but at the same time you introduce expensive round trips. So the communication between chains is expensive. And this is basically introducing this dilemma now. The flaw in the app chain thesis is that it neglects the value of synchronous composability and leans entirely into asynchronous composability. We're entering into new territory, but let's bring an analogy as a guide. The economy of a single blockchain is to a country's economy what the multi-chain economy is to international trade. As we have seen in the development of the global economy, countries have specialized in particular fields or areas of economic development. However, even those countries which import cheap goods from countries specialized in manufacturing retain capabilities locally. And vice versa, there is no country which has specialized entirely into one field to the extent of not having other economic activity locally. So let's say you have a country that is specialized into mining raw goods or into producing high-tech goods. Even though they have that, they will never neglect having supermarkets for people or having medical services and so on. So you will always have some generalized services available in any economy. The same approach is likely to be most efficient for the multi-chain economy as well. Chains will specialize, but not entirely. Chains will benefit most by retaining some generalized capabilities for the benefits of synchronous composability. So, practically, synchronous composability is instantaneous. The country analogy breaks down here because it's akin to each country having a teleportation service which only works within its own borders. So what he's saying is that within a chain you can have instantaneous synchronous composability. It's always happening within the same block. So this property implies that no matter how good cross-chain communication gets, the benefits of synchronous composability will never be entirely eroded. No matter how good a parachain can optimize for a use case, it can never be so good that it will never need, wouldn't benefit, that it would completely eliminate the benefit of having some generic capabilities, right? Generic capabilities will always make sense. Improvements in cross-chain communication will reduce the amount of generalization chains need to retain, but chains will always need to stay slightly generalized to provide the most efficiency. You could even argue this for Bitcoin. While Bitcoin is a super specialized chain, it's basically a calculator where you can like add numbers and subtract numbers. Even Bitcoin has seen the need to add a little bit more generalization to be interesting enough to be considered long term. So that's why Taproot was added, and that's why it's tapping a little bit into the territory of smart contract capabilities. So these hybrid chains will allow us to reap the benefits of both. Chain economies will specialize while retaining the generality and opportunity needed for rapid growth of products and communities. What the hybrid chain approach is likely to look like in practice is application-specific logic deployed alongside smart contracts with a limited amount of block space allocated to smart contracts. Okay, what does this mean? So you have block space. I think maybe let's go into his argument for block space. No, he's going there a little bit later. So this is basically the argument for hybrid chains. You have a lot of space allocated to specialized logic, but allocating a little bit of your space for smart contracts makes sense and gives the chain that bit more efficiency and expressiveness. The beauty of embedding smart contracts alongside specialized functionality is that the specialized functionality of a chain can be exposed directly and synchronously to the smart contracts deployed there, giving the smart contracts there an edge or differentiator to smart contracts deployed elsewhere. Basically, what it says is if you have smart contracts directly in a specialized chain, they can directly tap into that functionality and use it, exploit it. Given that contracts would only be able to consume some of the resources per block, the absolute costs of gas would be higher relative to chains that focus entirely on smart contracts, all else equal. This is basically the argument that if you have a very specialized chain, it will be more expensive to execute smart contracts just because the chain prefers to operate the specialized operations and not the generalized operations. So that is why generalized operations there are more expensive. But the contracts deployed there would be those that can create the most value from synchronously interacting with the specialized functionality exposed by the chain. Every chain, even app chains, should have smart contracts. Good. This is the first half of the article. Then there is a little bit of an addendum. So the second part, runtime composition and innovation arms. In Polkadot land, we refer to the business logic of the chain as its runtime. Chains acquire block space, and the runtime determines how to allocate this block space. So if you don't know yet what block space means, take a look at the article, and I made a video about it. Block space is a very important concept that can give you a very good outlook on how to look at crypto in general and what crypto can offer. So chains acquire block space, and the runtime determines how to allocate this block space. A raw material derived from decentralized trust. Runtimes written in Substrate are composed of pellets, which each provide functionality such as balance transfers, smart contract logic, or specialized functionality for particular use cases. The approach to building a hybrid chain in a substrate chain is simple. The first step is to build a runtime composed of pellets, some particular to a use case, and some generalized pellets for smart contracts. The next step is just to limit the amount of block space that all smart contract calls in a block are allowed to use. Substrate's wait mechanism makes this totally configurable in the runtime side by just having the runtime reject transactions over the limit until the next block. Block authors must respect this limit for the block to be valid. So this is basically the recipe on how can you make such a chain in Substrate. And the nice thing about Substrate is that it can be very flexible on how you allocate the block space. So you could say you want to make it completely free, and it doesn't matter if you use the specialized functionality of the chain or if you call smart contracts with general capabilities. Or you could say it's 50-50 or 90-10. So this is really up to the blockchain to decide how it wants to allocate the block space. Contract sandboxes can also serve as an innovation and growth engine for an app chain. Think about research and development departments in big companies, particularly those which provide intermediate products meant to be used by user-facing applications. So this can also be convenience functions on top of the thing. Smart contracts deployed alongside the specialized functionality create a simple on-ramp for developers to utilize it without having to interface with multiple chains, cross-chain messaging for the first iteration. And it could even allow a team itself to, if they have an idea, to create a smart contract before they build it into a pallet. Because building a pallet takes more time, it has to be more tightly integrated. And building it as a smart contract first could allow you to create a proof of concept, test out new functionality, or give other newcomers, developer newcomers in the ecosystem the chance to try out the feature and then present it. And over time, those features could come down into the palette land, into the palette level, and be integrated into the core logic of the runtime. The iteration speed of developing in smart contracts can be much faster, and these contracts can spin out into a freestanding blockchain once they have the community and user base to do so. As examples, consider derivative smart contracts or DAO treasury management living on a chain alongside a DEX palette, attestation service contracts living next to an identity palette, or chains deploying embassy smart contracts on another chain to manage these affairs there in a synchronous way, right? So possibilities are endless, and there is just, it would just allow everyone to interact in a way where it's less coupled. You don't need to create a new palette just to add functionality to a chain. You could also just add smart contracts. That is the argument. Each app chain can build its own innovation hub and onboard developers directly into the application, lighting a path for them to grow and scale. Substrate palettes are a powerful tool, but their power is enhanced by using them as building blocks for user-deployed code running in the same synchronous environment. Asynchronous composability lets us scale and expand, and synchronous composability lets us innovate, experiment, and grow. Okay, I hope you enjoyed this discussion here. It's definitely inspiring, and it's definitely nice to get a little bit of context when you're actively involved in Polkadot. You tend to see only the advantages of having specialized specialized chains, app chains, but this is actually a very interesting perspective. And I'm interested to see how teams will react to the argument and if it will be becoming a part of the conversation in the coming months. Thanks for watching. Make sure to follow me on Twitter @AlisandBob. Press the subscribe button here on YouTube, and all the best to you. Goodbye.